Alright, so let's move into problem number 37 now. This problem talks about truncatable primes. So what it says is, let's say this is an example of a number 3797. If you truncate from left or from right, you get numbers like this. From one side you get, this is from the left side, if you truncate you get 797, 97 and 7. Similarly, if you truncate from the other way, you will get 379, 37 and 3. Okay. So, and in this case, all of these numbers are prime. And here the question is asking, find sum of only 11 primes that are both truncatable from left and to the right. From left to right and right to left. So only 11 primes. Okay, that's what the question is asking. Okay, so let's jump into coding, and I'll just write down here problem number 37. So as you can understand, first problem we'll have to solve is we'll have to create a function that will take this number and give us all these truncatable values. And we'll have to try from left side and from right side, both way. Let's try to create that function first. Def get trunc numbers, okay, and I'll take this number as an argument. Let's say we'll have a list as our list that will contain all the number. Then I'll take a small number, lowercase n, and I'll assign this as a number. And let's see why I'm trying to do that. Because okay, let's create a while loop. While n greater than 0, I'll just append the number, because the original number should be also part of it. Okay, and then what I'm trying to do is n is equal to n integer division of 10. Why I'm doing that? Because you see, what was the number? 3797. 3797. Okay, if you take 3797 integer division by 10, you get 397. And if you keep doing that, that means next integer division, then you get 37. If you do it again, you get 3. So you'll get all the 3 number from one sided. Okay, so this will be from the left side. Okay, all the numbers. This is how you can get it. If you just keep doing that, you'll get all the numbers. It's like that. Okay, so that means after this loop basically we will get all the numbers from one side. Okay, so if I just want to print the list, if I just call our functions get circular numbers, let's say 3797. okay, sorry, I called the wrong function. So you see, we got all the 4 digits from this side, one-sided. Now we'll have to figure out from the other side, from right side. Okay, and let's see how we can do that. Okay, so to do that, I'll just start again small number with num. Okay, then here what I'll do, I'll just start with div as 10, and I'll keep multiplying div for the number of digits, which means I'll create a while loop n greater than div. I'll just multiply div equal to div multiplied by 10. Okay, so I got this div, and we'll just do one round extra here again, so I'll have to get back. So once I got that, then what I'll do while n greater than 0, n is equal to n divided by div. Next, what I'll do is I'll divide the div. Okay, I'll divide the div by 10. So we are trying to do the modular division of the numbers. For example, for this 3719, let's see what I was trying to do. If I just do a modular division of, let's say, 100, what will happen? I'll get 97. If I do modular division of 1000, I'll get 797. So that's what we are trying to do. Finally, if we do modular division of 10, you will get 7. So this is how we'll get the other numbers from the other side. Okay, so that's what we are trying to do here. List.append, we're trying this n. Okay, just appending the n, and that should do our job. Okay, let's see what happens if I just return list. Okay, and let's see if we get this. Yeah, so here we are getting everything except we are getting one extra 0, and even if I do one more, let's say 8, so I'm getting one extra 0. So just to remove that, I'll just take all but the last one. So we got our answer. Okay, so here I believe we'll have to do integer division. That's why you are getting this fraction. Okay, let's try that again. Yeah, so we wanted it as integer, not the float. Okay, so we got this thing, but the question is asking first 11 such numbers. Okay, how can I do that? Okay, first of all, let's create a prime dictionary again. Prime dictionary is equal to this. Then, prime dictionary of, okay, I'll just create a loop for num in range 2 to 1 million. I'll just try with 1 million because we don't know up to how many numbers we have to go to get the first 11 numbers. Okay, I'll just do this, and then I'll get prime dictionary dot append prime dictionary. Sorry, it will be the number is equal to is prime. We have created is prime multiple times, so I'm just using that is prime function number. Okay, so now I'm just getting this loop, getting this dictionary. Okay, sorry, I took more than 1 million, I took 10 millions. Yeah, so is prime is done. Now what we are trying to do is we'll have to check if the count is less than 11, then we'll stop our search. Okay, so let's try with count equal to 1. Okay, and then I'll create another list, that is the truncated prime list. List is equal to empty list. Okay, then I'm just checking while count less than or equal to 11. Okay, what we'll do is we'll just try the list is equal to get truncated numbers. We'll have to get all the truncated numbers from every number and check all of them has to be prime. Okay, so get truncated numbers of the okay, I'll have to do another thing. I'll have to keep what is the current number we are looping. Okay, so because here we are not using for loop, we are using while loop, so that's why we need this. Let's say current number we are starting with 11 because we know the number before that. Okay, so we can start from 11. Okay, for example, get truncated number. Here it says 2, 3, 5, 7s are not considered to be truncated primes. That's why I'm just starting with 11. Okay, I don't have to try with them. Now get truncated numbers. Okay, there is one more thing we'll have to consider. See, in this dictionary, if I just take our prime dictionary started with 2, but what about 1? Because when we are truncating it, we may get 1. Okay, so 1 also has to be part of our dictionary. So what I'll do, I'll just add another statement here, or rather outside prime dictionary of 1 is equal to, we know the 1 is not prime, so we'll just add this. Okay, and that should complete everything. Now get truncate numbers of current number. We'll pass the current number, get the truncate numbers, and then I'll try prime flag is equal to true, because remember all of the numbers in the list has to be prime for num in list. Okay, so if not prime dictionary of number, then prime flag is equal to false. Okay, now at the end of this loop we'll check if prime flag, okay, if prime flag here, then we are entering, so if prime flag, that means we'll have to increment our count plus is equal to 1, and truncated prime list we'll have to add. We have truncated prime list dot append this current number. Okay, current number. Okay, I think that should be it. Okay, let's try to print the current number, and we want to try with current number. We just don't want every current number. We don't want to try with every number. We will increment it by 2, so that we'll try only with the odd numbers from 11, 13 and so on. Okay, let's try to run it and see what happens. Now let's check our size. Okay, so what is the, okay, here we already gave 11, so that means we must have got 11 list of primes. Let's take this length. Yeah, we got 11, and 3797 is one of them. So question is asking for the sum of them. Okay, what is the sum of them? So this is the sum of it, and if we try, let's try if this sum is, this should be our answer. Yeah, our answer is correct. By the way, there is one thing, I have just used is prime function, which I have done in my previous problem, and if you really want to look at it, we'll look at the previous problem. Otherwise I'll just copy the functions for your convenience. Here is this prime function. Okay, so that's it for the current problem. Coming up next is problem number 38. Thanks for watching.